Hello students, myself Janardhan Dikshit. I am from Lucknow, Uttar Pradesh, and today I am going to take a small topic of organic chemistry known as electrophilic substitution in aromatic hydrocarbons. Why in aromatic hydrocarbons? Why? We will study here why the electrophilic substitution is more suitable in aromatic hydrocarbons and understand each and every word. So first of all, I write the heading. What we are going to study? We are going to study a topic of organic chemistry. We are going to study a topic of organic chemistry. What is the topic? What is the topic? The topic is electrophilic substitution electrophilic substitution in what? In aromatic hydrocarbons. Before reading or study the reaction, first we have to understand each and every word, what we are saying in this heading. First of all, what are hydrocarbons? Hydrocarbons are the compound which contain carbon and hydrogen atoms. Then what is aromatic? Compounds which follow Huckel rule. Now what is Huckel rule, sir? There are the different type of rules. What is Huckel and who is this Huckel uncle? Most of these scientists are from foreign. Now what is the Huckel rule? Huckel rule is 4n plus 2 pi electron system rule. Means if a compound have the pi electrons which follow this equation 4n plus 2 pi electron system, then the compound will be aromatic in nature. Now what is this n? N should be or can be 0, 1, 2, 3 and so on. Now if we put 1 by 1 0, 1, 2, 3, then the value we get from this equation is 6 first we get 2, then 6, then 10, then 14 and so on. Difference of 4. The first value is 2. If a compound contains pi electrons in this increasing order, then the compound will follow Huckel rule and it will be aromatic. Is this enough? This Huckel rule is enough for the verification of the compound is aromatic or not? No. The compound should be cyclic in nature. The compound should be first condition cyclic in nature. Cyclic in nature. What is the third condition? Third condition is conjugated system should be there. Means what? The p orbital should be parallel. You can understand from that. If you have some problem, then you can get a trick from here. If A, B, C and D are in the carbon chain, if A and B have double bond, then C should be double bond with D, triple bond with D, or C should positive charge on that, negative charge, free radical. You know about free radical? Single electron, free electron, then at last lone pair. And what is lone pair? The electron pair in the outermost shell which do not take part in the bonding. If this system is present anywhere, then what you will say? It is a conjugated system. For example, benzene. You can see here the system is cyclic. Now example of this is benzene. In benzene, what you can observe, it contains pi electrons. What is the number of pi electrons? 2, 6 pi electrons. Yes, it follows Huckel rule. Is it planar? Is it planar? Yes, it is planar. The fourth condition you can write here, the planar. Is it planar? Yes, it is planar. It is cyclic? Yes, it is cyclic. It is conjugate. It has conjugated system. Yes, it has conjugated system. Now, this is the meaning of aromatic. This is the meaning of aromatic. Now, what is the substitution? What is substitution? Let us take example. A and B react with C. React with C. If C replaces, suppose B and A and C form a new bond, B is replaced, we can say that this reaction is a substitution reaction. What is substituted? B is substituted by C. We get a new bond by breaking the old bond. This is substitution. And what is electrophile? Electrophile symbol is this, E and positive over it. It means electron loving or negative charge loving. These species themselves are electron deficient. They want to go at that position where the electron density or electron richness is more. They love the center. Where electrons are present, where electron density is highest. We all know that electrophile attack on substrate, and substrate, the position on the substrate where the electron density is highest, it will attack on that position. Now all the terms are clear. Then what will be the reaction? I take a benzene, and different type of electrophilic substitution are possible, but we are taking the example of nitration. How will you do that nitration? What is nitration? NO2 group substitution. No. We will substitute hydrogen from here and add a NO2 group. This is called nitration. Now how will you do that? We take concentrated H2SO4 and concentrated HNO3. H2SO4 is sulfuric acid, HNO3 is nitric acid, and we give some type of heat here. What I will get a nitrobenzene. How is it possible? So we have to go through mechanism. The real concept is coming now. Here we are taking two acids. Both are strong, but which one is the strongest? In comparison with these two, H2SO4 is more acidic. It means H2SO4 will release H plus. How I can say that? There are the different type of theory or acid and base. Arrhenius theory, Bronsted-Lowry theory, Lewis theory, Lux-Flood theory, different type of theory on acid and base character. But according to the Bronsted-Lowry theory, acids release H plus, and base accept H plus. Now this concept we will going to put in our mechanism. We will first draw the structure of H2SO4 like this, and some simplified form of HNO3 like this. Now what happens here? This is more acidic. This will release H plus, and this H plus go to the lone pair of O atom present in the HNO3 acid, and here we get HSO4 minus. H plus is released, then a negative charge here, HSO4 minus, and a new system is here. You can see this. In this system, if we extract H2O, H2O is extracted easily here. Why? H2O is a stable and neutral molecule. If we extract it, we get what? H2O, and this bond will be broken, and we get NO2 positive. NO2 positive. In this step, if you call it a first step. In this step, you would do a simple work: generate a electrophile. Nothing else you are doing. You are just H2SO4 as an acid. You are taking H2SO4 as an acid, and in the presence of H2SO4, HNO3 behave like a base. It is accepting H plus. So here I want to explain something you should understand, that all the trends, all the increasing decreasing order, all the stability reactivity characters, all the acidic and basic character depend on the conditions. Yes, HNO3 is a good acid, is a strong acid, but in the presence of H2SO4, which is stronger than that, it behaves like a base. So if you say that something is acidic in nature and always, no, it will depend on conditions, and it will depend on the species by which it is reacting. So here HNO3 behave like a base, and at the end what we get electrophile, and we get a conjugate base of H2SO4. We get a conjugate base from acid. When you release H plus, we get a conjugate, and this conjugate is a base, and this conjugate has a tendency now to attract H plus ion. So I have to rub something to write next step. Simple next step. Let's see, my friends. This is just organic chemistry for you. Very easy to understand. We get it. Okay. Next text. What we have get from the previous step? We get a electrophile, and we get a conjugate. We get a conjugate base. Now benzene was present there. Bring that on. In the presence of NO2 plus, which is acting as electrophile, benzene double bond break in one direction, and on the negative side NO2 is attached. On the positive side, still the work has to be done, and this is the system. In the next step, HSO4 minus is coming and want to extract H plus ion to regain its original from H2SO4. From where it will get H. Now observe here a H atom is present. This H atom releases as H plus ion. We get H2SO4. And see carefully, like this positive is there. Now here the negative charge is generated with NO2 group attached to it. This positive negative converted into a bond. Now here you gain the benzene ring, original benzene ring, and NO2 group on it. So this is a electrophilic substitution in aromatic hydrocarbons. Why this reaction is called electrophilic substitution? Because benzene is present. Benzene is electron rich in nature, and if it is rich in nature, electrophile will attack on that. To gain stability. If in a reaction first electrophile is added or substituted, then this is known as electrophilic substitution. Then the reaction name will go as the first thing added or substituted to it. Suppose a nucleophile is first attached or substituted, then the reaction name will go on as nucleophilic substitution, nucleophilic addition. Now here is the substitution is electrophile, then this reaction is known as electrophilic substitution. Aromatic hydrocarbons, I have explained you every word earlier. One more thing I should say, you have to remember that conditions matter in the organic chemistry, especially in whole chemistry, but in organic chemistry the most condition matter. All the characters, all the tendencies, all the increasing decreasing order depend on the conditions. You can see HNO3 is a good acid, is a strong acid, but in the presence of what, H2SO4, it behave like a base and accept H plus ion. Thank you so much. This is for you. We will meet again. Thank you.